Hello, everyone. Welcome to our webinar today. The topic of today's webinar is replacing power plants with low-income residential solar and storage. This webinar is presented by Clean Energy Group as part of the Resilient Power Project. Our host for today's webinar is Seth Mullendore. Seth is the Vice President and a Project Director here at Clean Energy Group. We also have some excellent guest speakers with us on the line. Before I pass it over to them, I'd like to go over some quick housekeeping notes. All of our attendees today are in listen-only mode. You have a couple of options to join the audio portion of the webinar. You can call in via telephone, or you can connect via your computer's mic and speakers. If you'd like to minimize the webinar console so that you can view the webinar slides full screen, simply click on the little orange arrow that you see circled here. You can also use that orange arrow to expand the webinar console. Following our webinar presentation, we are saving about 15 minutes for Q&A, maybe a little bit more, with the audience. We have a lot of attendees today, so we ask that you please submit your questions by typing them into the questions box on your webinar console when you think of it, and we're going to try to get to as many as possible. To make sure that we can get to your question, please make sure you type them in when you think of them. Finally, this webinar is being recorded. We will post a recording of the webinar on our website, and we will also send you a follow-up email within about 48 hours with a link to the webinar slides and recording. With that, I'm going to pass it over to our host for today's webinar, Seth.
Thank you very much, Mari, and thanks to everyone for joining us today. It's going to be a really great webinar, and as Mari said, we've got a lot of folks signed up for this, and so please submit your questions as you think of them. So I'm going to give you a little introduction to who we are and the project bringing you the webinar today. So we are Clean Energy Group. We are a national nonprofit, been around for 20 years now. And we are completely funded by foundations. You can see the foundations that support us here. And we work across the clean energy sector, looking at advancing innovations in technologies, finance, and policies, with a focus recently on solar and energy storage. We also have a sister organization called Clean Energy States Alliance. Clean Energy States Alliance is a membership organization of organizations that represent or manage state clean energy and energy efficiency funds. And there are a number of states that are members of that. So the webinar today is coming to you through our Resilient Power Project. The Resilient Power Project has been in place for about 6 years now. Really came in the wake of outages that hit the Northeast after and during Superstorm Sandy. And we've expanded that effort across the country since then. Most recently, we've been doing a lot of work in Puerto Rico. The goal of the Resilient Power Project is to expand access to resilient power technologies, and that's really based on solar paired with energy storage, sometimes with other power systems as well, specifically for disadvantaged communities that are hit hardest and often have the least resources to recover in the wake of power outages. So we work specifically with low-income communities, communities of color, and otherwise disadvantaged communities. We do this work on a number of different bases. We work on doing a lot of analysis around solar and storage, and we do a lot of reports that we put out through that. We work on policy to help enable programs and policies that will bring more access to solar and storage for disadvantaged communities, incentives and demonstration projects and otherwise. And we also do a lot of support on the project level, trying to make sure that projects get built in these communities and can benefit disadvantaged communities, both for resilience and for lowering energy burdens and bringing opportunities to generate wealth into underserved, under-resourced communities. So through that, we've worked as facilitators in over 150 different projects across the country. Not all of these have been built, but there are a few examples here of projects that have been built and efforts that are currently underway. So a lot of our work is in the Northeast. That's where it began, but we've since expanded that program to a lot of other places. We provide high-level assistance ourselves, and then for some projects, we can also provide some small grant support to bring in outside engineering expertise to do technical and financial feasibility. You can find more information about the Resilient Power Project on our website, resilient-power.org. And with that, I am going to introduce our speakers today. We're very lucky to have with us two great speakers on this really exciting topic of replacing power plants with distributed generation, solar and storage, and this is specifically talking about a project that's targeting low-income households. So first up, we're going to have JP Ross, who's the Senior Director of Local Development, Electrification, and Innovation for East Bay Community Energy. He's been actively engaged with solar market development and commercialization since 1999. After completing a master's degree from the University of California, Berkeley, JP joined Greenpeace to advocate for wind and solar as an alternative to 50 gigawatts of new gas plants in response to the California energy crisis. JP then moved to Vote Solar and successfully campaigned for California's Million Solar Roofs initiative that helps make solar energy the most cost-effective source of energy. JP led Vote Solar's activities in pro-solar rate design regulatory proceedings across the U.S. In 2007, JP moved to Sungevity, where he helped grow the business from 4 to 750 employees as the third largest residential solar installer in the U.S. JP developed and managed Sungevity's procurement and installation operations, market expansion, strategy, and channel development. Then in 2015, JP joined Origin Energy, Australia's largest energy utility, where he led the development of Origin's business solar PPA, IT program, and channel strategy. JP, as I said, is now Senior Director of Local Development, Electrification, and Innovation at East Bay Community Energy. And that is a community choice aggregator serving electricity to 1.5 million people in Alameda County. Then we're going to hear from Michael Norbeck, who is a Senior Manager of Grid Services for Sunrun, Inc. He leads business development for Sunrun's Grid Services team, positioning the company's solar and storage products to create value as grid planning and operational resources. Before joining Sunrun, Michael held multiple positions at Pacific Gas and Electric Company, heading energy efficiency finance product development, and most recently leading competitive solicitations for non-wires alternative projects as part of the utility's integrated grid planning team. Prior to Pacific Gas and Electric, Michael worked in supply chain sustainability strategy for multiple Fortune 150 manufacturing companies and in energy infrastructure management and emergency response planning at the U.S. Department of Energy. He holds a master's in public administration from Indiana University and a BA in public policy studies from the University of Chicago. So with those introductions, I am going to now turn things over to JP Ross.
Great. Thanks very much, Seth. Thank you all for joining us today. We're really excited to be talking about this concept and the innovation that is evolving in the market that CCAs are and oftentimes leading and collaborating with companies like Sunrun to bring to the market in order to address some of the challenges that we face in meeting our obligations to serve. I am not able to advance the slides right now, so maybe I need to get control of that. We could advance to the next slide, that'd be great. There we go. So EBCE is the community choice aggregator serving Alameda County here in California. We are serving about 560,000 meters, a little over 1 million residents in the county, and we started serving customers in June of 2018, enrolling our commercial customers at that time, and then we commenced enrolling residential customers in November. So we are just under a year of full operational service here in Alameda County. We serve about 6 terawatt hours of load and almost $500 million in revenue per year. And our board is made up of elected officials from each of the 12 participating cities and the unincorporated county of Alameda. So we take our direction from those elected officials, which really means we are close to our customers and residents, and really take direction from the people who we serve. And instead of sending profits to investors and Wall Street, like our counterpart in the investor-owned utility space does, we invest earnings back into the community with a focus on creating local jobs, local energy programs, and clean power. And that's what I manage as Director of Local Development. And that focus is extremely important for EBCE, as we have a lot of customers with varying needs that are specific to this region. And a couple of points that are really interesting to note, a lot of our territory is disadvantaged communities as defined by Cal EnviroScreen. And we have over 100,000 or just under 100,000 care and FARA customers. So we have about 500,000 residential accounts. Almost 20% of those are defined as low income. So we have a low income population that is impacted environmentally by not only energy, but transportation and air quality impacts. And about 50% of our population is renters. So we have communities that need special service and may not have been participating in some of the developments certainly in the solar space and the residential solar boom that has been hitting across California. Certainly Alameda County has many solar systems. We have over 250 megawatts of solar currently installed, but there are parts of our community that have not been able to participate in that activity. We serve as our base requirement, as a load serving entity, we serve 3 different products. We have Bright Choice, which is our standard product. About 80% of our customers are on Bright Choice, which is a little bit cleaner than PG&E. Last year it was 90% carbon free that was provided to customers, and that's at a 1.5% discount to grid to PG&E's pricing. We have our Brilliant 100 product, which is 100% carbon neutral and indexed to PG&E's price. And then we have our Renewable 100 product, which is 100% wind and solar at a 1 cent per kilowatt hour premium. And many of our cities have actually opted up all of their meters to Brilliant 100, and some of our cities have opted up customers to Renewable 100, and that occurred at enrollment. So overall, the electricity that we are providing to our customers is significantly cleaner than the alternative that's being provided by PG&E. So the energy future and the climate of energy in California is quite interesting. We have several laws and targets in place that are going to significantly increase the penetration of renewables. We have SB 100 targeting 100% renewable energy in the state by 2045. And of note, solar is now the most cost-effective resource. Behind the meter solar is incredibly cost-effective, and utility scale solar is very cost-effective. The average cost of new solar contracts that EBCE has been signing is $22 a megawatt hour, which is 2.2 cents a kilowatt hour. It's incredibly cheap to install new solar, and that will drive the majority of new renewable energy into the state. We also have a target of 5 million electric vehicles by 2030, and a high degree of investment in charging will be necessary to support that accelerated growth. EBCE expects to have around 250,000 vehicles installed, electric vehicles, in the county by 2030, which will have a significant impact on our load growth. Now, that penetration of new renewables is going to create some challenges in the market. And the challenges will be great when there is a massive amount of overgeneration from solar during the middle of the day, and we have a less and less responsive fleet of other assets that can fill in the gaps, and that creates a resource adequacy constraint that I'll go into later. But the point of this slide is really to note that there will be a large degree of new solar coming into the market, and we need to find ways to manage that growth and manage that energy. We, as a load serving entity, have to not only procure enough energy, but we have to make sure we have energy at the right time of the year and the day, and energy and capacity, and balancing those is critically important to making sure the lights stay on. As many of you are probably aware, PG&E has turned off about 20% of their accounts over this PSPS event. So reliability and resiliency are going to become increasingly important. And as we move to decarbonize the economy, there are many sectors that must change over to electrification. So as we decarbonize, we have to decarbonize our buildings, we have to decarbonize our transportation, we have to decarbonize the electricity sector. Now, the electricity sector is actually one of the easier ones to decarbonize. As I said, our standard product in 2018 was 90% carbon neutral. So there's a lot of carbon that's already been driven out of the electricity sector. And that's great, but as we electrify these other resources, building electrification, vehicle electrification, we expect to see a tremendous amount of load growth. So EBCE is currently at 6 terawatt hours. Through vehicle and building electrification, we would expect that to almost triple over the next 30 years. So once again, massive load growth, and the resources that we have to meet that growth, solar and some wind, non-dispatchable resources, we need to figure out how we're going to store that energy and make it available when our customers need it. So this is occurring at the same time that we see resource adequacy on the decline. So there are lots of retirements that are forecast in California. Of note, Diablo Canyon will be coming offline in 24, 25. We have once-through cooling plants that have been scheduled to be decommissioned for quite a long time, have recently been given another lease on life by the PUC, but are still over time going to be decommissioned. About 2 gigawatts of CHP plants are set to be decommissioned, and then imports are being constrained by the PUC in some ways, or imports are going to be used up by other states that are building their own and increasing their own clean energy requirements. So, for example, hydro from the Northwest is going to be consumed more in the Northwest than exported to California, because Washington and Oregon are having their own carbon plans. So we expect that over the next 15 to 20 years, or 10 to 10 years or so, retirements and imports are going to further constrain capacity in the market. So that leads us to where we are today. We are aggressively signing new clean energy contracts. We've already signed contracts for almost 600 megawatts of new solar and wind, some of that located here in Alameda County, as well as 137 megawatts of storage. Our PUC mandated storage contracted amount is 12 megawatts, so we're have already 10 times our current storage in contract. We're moving aggressively towards this path, and this is all with having launched less than a year ago. The average price of the new solar is $22 a megawatt hour. It's incredibly cheap to do in front of the meter solar, and we want to figure out how we can match the value of behind the meter solar with new storage. So we have over 250 megawatts of existing solar and 15 megawatts of storage already installed in our service territory. And as battery electric vehicles and stationary storage come into the market, we have to also figure out how we are going to utilize those resources to meet our RA constraints. The electric vehicle technology is a great technology. We are very focused on accelerating electric vehicles into the market, not only as vehicles for customers to get from A to B, but also understanding what the capacity value of those vehicles is. By 2025, we expect to have about 86,000 electric vehicles in Alameda County. That'll add about 10% to our annual load, but it also represents over 10 times our peak load in battery capacity in those vehicles. So understanding how to manage and utilize mobile sources of storage as well as behind the meter storage is increasingly important. And we expect that PSPS events like the one we are experiencing right now is going to increase the appetite for behind the meter storage. And it's one of the reasons we are very excited to be working with Sunrun in our OCEI project, which Michael will talk about shortly, as a key and a mechanism to unlock the potential of behind the meter solar and storage assets to not only meet our resource adequacy requirements, but provide additional resilience to our customers who, in many cases, for example, with medical baseline customers, can't afford, it's a life and death situation to be out of electricity for days at a time, which is what customers can now expect. So we need to understand what are the mechanisms to drive increased penetration to not only wealthy individuals who can purchase and afford to install solar and storage, but also harder to reach communities who need some help, need more help getting the resilience that everybody deserves in order to lead healthy, happy lives here in Alameda County. And I'll end with saying one of the things that we are now very close to releasing is a new solicitation that will go out to the market in the end of October this month, that will be built on the OCEI example that we have developed with Sunrun. And we will be going out to market for a minimum of 10 megawatts of resource adequacy to increase resilience in our customers over the next couple of years. We really need to accelerate this behind the meter storage opportunity as we go into kind of increasingly uncertain times from a resource adequacy perspective, and now increasingly uncertain times from a power reliability perspective. So with that, I will pass it over to Michael, who can talk in more detail about the solar project that we are progressing.
Thanks, JP. And this is Seth. I'm just going to, for those of you that are not following the California events as closely, PSPS event is a public safety power shutoff. It's basically PG&E is de-energizing, shutting off power to nearly 1 million customers because there's a threat of wildfire due to dry and windy conditions. And this is becoming a more and more common occurrence. So just wanted to add that before turning it over to Michael.
Great. Thanks, guys. Can you hear me okay? Seth, am I coming in all right?
Sound great.
Perfect. Well, I wanted to thank everybody for their time today. I know folks' calendars fill up pretty quickly, and we really appreciate you making time for the conversation today. Seth, appreciate the opportunity to speak with the group here that you guys extended, and want to commend JP and his team at EBCE for their leadership and their strategic vision in this context. Really, we are, committed to building a planet run by the sun. We are committed to grid resiliency and reliability to the extent that we can be a partner in that, and we want to show up right for our communities too. Key to that for us, I'm a business development guy. It's my job. So key to that is figuring out how we do that in the right commercial way. At least from where I sit, and JP and team have been again just great partners in going through the thought process with us and figuring out how we reach solutions that make a lot of sense for us as a company and make sense for the community and for them. So just very grateful for the opportunity here. I only have a couple of slides. They do have a ton of text on them, so I'm going to step through each of them relatively slowly. And again, we should have plenty of time at the end of the presentation for any questions folks have. But looking forward to getting as wonky as you guys would like, and we'll sort of see what comes up in the questions for that. But essentially, the project that JP touched on, which is where we're collaborating with EBCE for this phase, is called the Oakland Clean Energy Initiative. And it presented a really interesting challenge for us. Essentially, since the 1970s, there has been a jet fuel-fired power plant burning kerosene, so that's, again, the fuel that goes into jet planes, in the middle of Jack London Square, which is right adjacent to downtown Oakland. So I'm not sure how many folks on the call today are from the Bay Area. JP and I are both East Bay residents. I live pretty near Jack London Square. I get down there all the time, and I got to tell you, it's not a great place for a power plant, especially a really old one. However, based on its location and operating characteristics, the plant has been seen to be critical for maintaining the reliability of the grid under transmission system contingency planning scenarios. And we'll talk about these in just a sec. And this determination has been made by the California Independent System Operator. So the California Independent System Operator is a nonprofit organization that is tasked with maintaining the safety and reliability of the bulk power, so that's the high voltage system in California, and a little piece of a couple other states, but mostly California. It's also tasked with maintaining open access to wholesale markets for power and power products in California. So CAISO works with PG&E in this case to maintain safety and reliability of the T system, transmission system. An N-1-1 scenario essentially is if there is an asset, such as a line or a power plant, for example, that is deemed critical for maintaining reliability to a particular part of the grid. N-1 is where one critical transmission reliability asset is taken offline. So it's a line that's no longer operating or a power plant that goes down. N-1 is kind of that edge case where you have one transmission asset going down and then another one shortly following it. So you have two concurrent critical asset outages at the same time. This is kind of like one of the worst case scenarios that CAISO and PG&E have to plan for. And essentially CAISO said, well, based on the possibility for an N-1 scenario to occur, this plant, this old power plant, is a critical grid asset. So it's meant to help us manage that edge case grid reliability scenario. And as a result, CAISO signed a contract with, it was Dynegy at the time, the plant has since been purchased by Vistra, but a contract called a Reliability Must Run contract, where essentially CAISO says, because you are critical for grid reliability, power plant, or Vistra in this case, you have to keep that plant running when we need you, right? You have to be available to turn on if there is a grid reliability scenario that we've talked about. Now, historically, a lot of plant operators have been interested in Reliability Must Run contracts, or RMR contracts. It's a way to get the costs of operating your plant covered. But what's interesting is, typically over time, plant operational costs increase. And based on the way RMR contracts are set up, it can be harder and harder to ensure kind of profitability of some of these older plants over the lifetime of the RMR contract. So you're seeing more and more in California, some of these plant operators being interested in actually not running their assets anymore, but CAISO saying, look, we need you to stay on the grid because you play a critical reliability role. So just some of the context for what went into the development of the project and the role that we'll talk about for EBCE and for Sunrun and getting the clean energy resources brought online that are going to help the plant go offline. So this plant, we'll call it the Dynegy plant, only runs a limited number of hours per year, but when it does, it generates significant pollution. Again, 1970s vintage plant, burning kerosene, not a good look environmentally. This pollution from the plant, of course, also disproportionately is going to impact low-income communities and communities of color in West Oakland. So these are folks who are already experiencing very heavy burden from emissions stemming from operations at the Port of Oakland and other nearby industrial activity. Again, I don't know how many folks are familiar with the West Oakland area. Very busy. The Port of Oakland gets a ton of traffic every day. You have large container ships coming in. You have lots and lots of diesel trucks. It's a very, very busy, heavily industrialized area, which means a lot of negative environmental externalities for folks who live in and around the area. And the Dynegy plant, in this case, is contributing to a pretty significant environmental justice concern. So we, of course, are very motivated to do what we can to ameliorate some of that pollution. So kind of with all this as backdrop, a couple years ago, CAISO, Dynegy, and PG&E started trying to figure out how can they retire this RMR contract and find a solution that will maintain grid reliability at the same time, right? So again, PG&E doing a lot of stuff we're not crazy about right now. PSPS is a very serious concern and is impacting, over 1 million people now. It's a really bad deal. They make a lot of choices that we're not crazy about. You do got to give them credit at least a couple of years ago for having some vision to figure out how to work with CAISO to get this plant retired. I think more importantly, for the sake of the conversation today, we have to highlight the vision of EBCE here in stepping into this conversation as well. So EBCE knows that it needs to procure capacity products proportionate to meet its load. So again, this is that resource adequacy product, and we can talk a little bit more about what that product is and how it's delivered and stuff if folks are interested. If you are, enter your questions into the chat box, and we can dive into that during the Q&A. But essentially, EBCE knows that it needs to procure RA. The retirement of this plant, to the point that JP mentioned earlier, makes less of this RA resource, essentially, makes it less available, right? So the plant can create RA if it operates. Taking the plant offline means there's less RA available on the system. And of course, EBCE is committed to bringing clean energy solutions to the communities it serves. So JP and team stepped up and said, look, we know we have a great opportunity to help address an environmental justice consideration in our backyard. We know we have a great opportunity to bring clean energy solutions to our communities, and we want to figure out how we are a part of this project that'll bring the plant offline. So into that context, we stepped as Sunrun to figure out how do we bring a technical solution that will help. Forgive me, I clicked too far forward here. See if we can go back one. Okay. Technical solution that will help, again, create this resource adequacy product and maintain grid planning and reliability. So at a high level, and I'll spare you too much of the detail here because we could spend a lot of time talking about kind of the technical configuration of the asset. But at a high level, we are going to be installing solar PV and battery energy storage at affordable multifamily housing properties in West Oakland and elsewhere in Alameda County. So we are going to be directly addressing the grid planning and reliability issues in the load pocket that old Dynegy plant would otherwise be helping to address. The solar that we'll install is going to deliver cost savings in the form of bill reductions to all the folks that live in the affordable multifamily properties via the virtual net energy metering tariff. So we install the solar that saves folks money on their energy bills every month, and the storage will provide backup power for critical common area loads in these buildings. That could be lighting, elevators, space conditioning. One quick story that I tell about the need for backup power in common areas. Folks may be familiar with this scenario, but a couple of years ago, there was a significant heat wave in New York City. Parts of Con Ed's system, so that's the utility that serves New York, lost power. And included in those parts of the system that were without power were at least a few high-rise residential buildings. Now, tragically, that meant that the temperature in those buildings spiked, and folks weren't able to evacuate quickly. And it's awful, but a couple elderly people in those buildings died. Their units got too hot; they couldn't get out of the building in elevators. They couldn't see where to go because the lights were out. So we want to be a part of a solution that prevents that from happening in our communities in California and elsewhere as Sunrun, right? We want to make sure that doesn't happen again. And backup power for these common area loads like lighting and elevators and critical cooling functions in buildings are what we can deliver with energy storage. So we want to be a part of that community resiliency resource and make sure that we are doing our part to care for our most vulnerable populations. So as we touched on a little bit ago, we will bring together or aggregate all these storage assets, so all these batteries, into a virtual power plant. So it's basically just an entity that performs the function that a power plant otherwise would, that will deliver that resource adequacy product to EBCE through participation in CAISO markets via what's called the proxy demand resource or demand response. It's a demand response mechanism, that tariff, right? So this is the path we have to creating capacity product revenue from the resources that we can bring together to serve the community in EBCE here. I think there are some opportunities for us to explore different ways of delivering that capacity product. The PDR tariff is not ideal. It's pretty complicated and difficult to manage. We figured out a way to do it, but there's a lot more potential and value and efficiency that can be unlocked if we explore, I think, other tariff mechanisms and options. And we will be kind of figuring out the best path to advocate for those rules changes, because if we get those rules changes, that just means we're going to be able to bring the benefits of solar and storage to even more communities in California to start. So just wanted to flag kind of what some of our forward-looking strategy might be here. Again, we're figuring it out, but we just see more value that we can realize if we can help some of our regulators kind of understand a more efficient way to approach solving these problems. We've touched on this also, but just to summarize here, the capacity delivered from this virtual power plant will facilitate the retirement of that Dynegy plant and maintain grid reliability in that load pocket in Oakland that the plant is currently serving. So again, to zoom out one click further, bill savings, resilient power supply, and reducing pollution in a priority environmental justice community we see as a win-win-win. So we're really excited for the opportunity to serve the community and to partner with EBCE in delivering this clean energy resource. See, I'll click one more here. Okay, cool. So we've touched a little bit on some of our collaboration with EBCE. We are super excited about this partnership. Together with EBCE, we're going to deliver clean energy, bill savings, and resilient backup power to communities of concern in Alameda County. We will also, and this is where it gets really interesting for us going forward, is we're going to use the contract we signed together as a starting point to help create efficient scale delivery of capacity products from aggregated customer-cited resources, right? So this is like our proof of concept. This is the industry and, a load-serving entity coming together to say, this is what the future of a distributed, resilient, carbon-free grid looks like. And here's how we build that while serving the communities that are typically under-addressed from a technology and clean energy standpoint. So really excited for that and for what the model that we build here can make possible for all of us in the future. And to that point, this is going to empower our communities to play an active, engaged role in building that cleaner, more resilient grid, right? So this is a community-centered focus to building the grid that we all know is possible and that we're also motivated to see take shape. We hope to bring the model that we're building here, and we think our odds are very good, of bringing this model to more communities in California and elsewhere, and expanding it to include sites like schools and community centers and fire stations, other kind of public facilities that can serve as critical community resiliency resources, especially when you're seeing grid service disruptions become more and more common in response to severe weather events and other challenges, right? So we're building the model with low-income multifamily, residential properties now, critical segment of the community to address here. And we know we can go even bigger. There are a lot of other public facilities where there's available roof space and available floor space for solar and for batteries. And these are places where folks will come when there is a grid outage, right? We want to figure out how to, engage more and more properties like that and public agencies that manage them to help us think even bigger about what a resilient grid can look like. So I wouldn't be a biz dev guy if I didn't put a quick pitch in at the end, but I would say, feel free to contact us, here at Sunrun if you're interested in this stuff and you want to explore some partnerships. I know we have a very diverse group of folks on the call today, and there's going to be a lot of good perspectives and a lot of interesting geographies represented. So if you want to learn more about what we're working on and explore opportunities for partnership, we're always happy to chat. My contact info is in the slide here, and I think Seth and team will send these out to the group. So feel free to drop me a line anytime, and just really excited to see, again, what the future that we get to help build looks like. That's all my formal content. I wanted to leave as much time as possible for Q&A, so I'm going to go back on mute and hand it back over to Seth.
Thanks so much, Michael, and thanks to JP as well. We do have a lot of questions. A lot of very good questions have come in. So we're going to get to as many questions as we can. As Michael just said, we are recording the webinar, and we will send around a link to the recording as well as the slides will be made available to folks in the next day or so after the webinar. So we'll be sending those all around. We're going to get to as many as we can in the allotted time here. We got about 20 minutes. We may also stay, I think both of our panelists can stay over for about 10 minutes. So we may stay around on the line. For those of you that have to drop off, again, we'll be recording the whole thing so you can jump to the end to see what questions came after you went off the call. So one point of clarification, Michael, as far as the systems that are being installed through this program, is it all multifamily or is there some single family installations as well?
Great question. So the bulk of the capacity that we intend to deliver will be from multifamily systems. You get economies of scale there. You get larger batteries, which is very useful for us and for the sites as well. We may end up including a limited number of low-income single-family households in the product that we deliver. We haven't figured out that last little piece yet, whether we're going to address it with a multifamily site with a slightly larger battery or a few single family sites, but the vast majority of the capacity that we will install will serve low-income multifamily customers.
Great, thanks. So a number of questions came in on the financing funding side of this. So who's paying for the batteries and the solar? How does the ownership work? How does funding work? Financing? A number of questions kind of in that general area. So maybe if you can give a response to that, and if any of the more detailed questions don't get covered, I'll get to those as well.
Sure. So I will just talk about how Sunrun kind of typically looks at deploying projects of this type. We are continuing to figure out what the right scalable model is going to be in California and elsewhere, but I'll talk a little bit about our current experience in California. Typically for resources like this, Sunrun owns and operates the asset and provides all operations and maintenance for the life of a lease or a power purchase agreement contract that we sign with the facility or the property owner. So in the case of affordable multifamily property, it would be the building owner or operator. Sometimes that is an individual or a corporation. Sometimes it's a public housing agency, right? And we sign a contract with them for delivery of the solar and storage. California, I got to give our policymakers a good amount of credit. They have done a great visionary job making a lot of incentives available to help projects like this make economic sense for folks like us. So we have the solar on multifamily affordable housing. That's the acronym is SOMA. We have that incentive, which helps us make projects pencil well on the solar side. It contributes to our project economics. We also have the self-generation incentive program. And again, our regulators just approved a couple additional SGIP budget allocations, an equity and an equity resiliency budget allocation, which help incentivize installation of storage technologies at under-addressed customer segment sites. So good, incentive dollars are available. They help us figure out kind of what the scalable business model is here. I would say, we would aim to be in this business, even without the incentives, but they help us bring these resources at a larger scale to more communities faster. So that helps us on the project economic side.
Okay, so I have a follow-up. Just you mentioned the solar on multifamily affordable housing program. So my understanding of that program, and correct me if I'm wrong, is that the solar is a front of the meter installation, and if that is the case, are you able to then tie the solar into the batteries behind the customer meter in order to provide that resiliency benefit in the event of an outage?
Yeah, great question. So, the solar will power the battery, right? So that also helps us ensure that we can capture and monetize the investment tax credit that requires your resources, your storage resources, to be charged from a renewable energy source. So it's in our interest to make sure that which also again helps us deliver the battery more cost effectively to our customers. So it's in our interest to ensure that the batteries are going to be solar charged. The virtual net energy metering tariff, the devil is in the details there with respect to where the solar resource is positioned in front of or behind the customer meter. We know that we need to allocate at least 51% of the output from the solar asset directly to offset customer bills. Typically, the complexity resides in whether the facilities are individually tenant metered or are master metered. Typically, if they are master metered, it's an easier configuration for us to ensure that the cost savings from the solar production are delivered to tenants. But again, it's going to the exact configuration is going to vary a bit site by site.
Okay,
and
great.
Seth,
Yeah,
this is JP. Just wanted to add to the last question about financing is part of the revenue stream here. The ongoing revenue stream will be the procurement of resource adequacy as a commodity from EBCE to Sunrun. So we provide that ongoing payment on a $1 per month, $1 per year basis. And that ongoing payment is, for the operation of that battery to meet our resource adequacy obligations. And then that also helps Sunrun deliver these resources to customers, at a kind of a lower price to make their end price to those customers more cost effective and accelerate the distribution of Solar+Storage.
Great, thanks. Yeah, that's a good point. That kind of contracted revenue source is extremely important for financing, particularly on the storage side. In this case, that's a good lead into another set of questions that a number of people had, just on the batteries being used for resource adequacy for that capacity, and then being available to customers for outages. Is there a certain portion of the battery that is set aside for the resilience, for the supporting critical loads in an outage, or is there some consideration taken into account for the operation of the batteries when potential outage events are on the horizon?
Yeah, great question. So first of all, JP, thanks so much for highlighting the RA contract construct. I don't know how I managed to gloss over that critical piece for us, and that really is one of the central elements of our partnership with EBCE. The RA revenue helps us bring resources that are more efficient and scalable to more customers. It's an additional way to stack value for us that translates into a more affordable product for everybody. So again, grateful to JP and his team for the opportunity to contract with them, and that's again a key part of the model that we'll look to extend. Let's see. So in terms of reserving battery capacity for backup, so typically we reserve a portion of the battery's capacity. So this is independent of any other services the battery could be provided to the grid. But typically in the range of 20 to 30% of that battery will be set aside for customer backup. So this is, if the battery is being used in the case of a multifamily property to help the ultimate bill payer save money based on time of use rates. So we'll discharge the battery pretty frequently, especially during summer months, we anticipate, to help them save money when they're in a peak period for power usage charge. We will always reserve a portion of that battery to provide that critical load backup, again, in the event of a grid outage. So yeah, we always maintain a portion of the battery capacity independent of any market or grid services operation to provide that critical load backup to customers.
Great. So that's another interesting question. Are the batteries being used for customer benefit aside from resilience? Any economic benefit that they're being tapped into for these projects, specifically for the customers?
So we're going to. Sure. So we're seeing rollout of time of use tariffs that will touch multifamily customers in PG&E service territory pretty soon. They've already come to SCE, that's Southern California Edison, and San Diego Gas and Electric territory, and they're coming to PG&E quite soon. That means that if you guys are probably pretty well aware of how this stuff works, but essentially that means that when you are during certain times of day, so it's typically 4 to 9 p.m. or 3 to 8 p.m., the rates are going to get much higher for using power during that time period per kilowatt hour. So you're going to be interested in a resource that will help you offset as much of that energy usage that you're experiencing as possible during that time frame. So hold on one sec here, guys. Sorry about that. The batteries will be used to help customers save on their bills during the TOU period, and we also work to deliver RA, resource adequacy, when the CAISO calls for it.
Oh, that's excellent.
Yeah, I would add to that. This is where policy, rate making, and regulation need to be very well aligned. So as Michael says, the TOU periods are actually being modified now to be later in the afternoon from 4 to 9 p.m. And that will drive batteries to operate such that they are collecting storage or collecting solar in the middle of the day when it has lower value because there's so much solar going into the grid, storing that energy and then discharging it later in the evening from 4 to 9 p.m. That maximizes the benefit to the customer through TOU, time of use arbitrage. And those 4 to 9 hours are also the 5 hours where resources need to be online to meet resource adequacy obligations. And so making sure that our utility rates are paired with the underlying fundamental drivers of pricing in the market is critically important, and then you can deliver that value to customers and provide the resources that we need coming online during those time periods. And when those things are offset, that creates market discontinuities that are, difficult to overcome. So it's really good that the TOU period is moving later, and we need to make sure that the rates are keeping up with the market dynamics, which are changing at an ever accelerating pace as we move into a decarbonizing economy driven by non-dispatchable resources.
Yeah, thank you, JP. That's an extremely good point, and I know we see that in all over the country where the regulatory process moves at a much slower pace than technology distribution and innovation. So excellent point there. A question for you, JP, and this is something we actually talked a little bit about prior to the webinar starting. There was a question just in light of the shutoffs happening right now that PG&E is doing. There was a question just asking about the resiliency for East Bay Community Energy customers versus PG&E, and if there is any difference there, or if there's anything that you guys can provide to improve the resiliency of your members.
Yeah, so we buy and sell electricity to our customers, and we are 100% beholden to PG&E's transmission and distribution system. So, the underlying infrastructure that supports the delivery of our product is subject to the whims and wills of PG&E and their investors. Obviously there's PUC oversight on that as well. But as we can see today, there's almost 20% of PG&E's base is out of power today. So, I think the way that we will deliver increased resilience to our customers is through programs like the one we are doing with Sunrun and accelerating those programs to our customers. The behind the meter storage opportunity, the increasing opportunity to use vehicles, first to manage loads on the grid and eventually to, be capacity for the grid, are things that we are moving very rapidly to not only pilot, like we're doing with Sunrun now, but then quickly move to the next phase, which is what we'll be doing with this solicitation that we'll be releasing in a couple of weeks, to really build off what we've started with Sunrun and really roll it out to a much larger swath of our population. I think that's the way that we're going to increase resilience, is not through more large-scale infrastructure, but through more distributed resources that we can deploy much quicker and safer to provide that value back to our customers.
Great, thanks. And this is an interesting and important question that I'm curious if either of you can answer. There's a question just about the job impact of the power plant, the peaker power plant that's going to be closing, and is there a just transition plan in place for the folks that will lose jobs when that plant is closed down?
Yeah, I do not have the details. What I do know is that all of our agreements are for either prevailing wage or for our larger scale installations, 5-party labor agreements. So we have provisions for wages across all of the projects that we are doing. As to the specific jobs of the current Dynegy employees, I don't have details on that. What the company Vistra, who's been operating the plant, is also the company that is installing 20 megawatt battery at that facility, and then we have another 7 megawatt battery as well that's going in as part of our front of the meter battery storage in order to close that Dynegy plant. So it is the same company who's going to be operating the new battery at that facility.
Great, and I can say from my understanding of plants like this that are infrequently used, they are not huge job generators because they are not used a lot. It's different than a large baseload plant that may employ a lot of folks. But that, of course, the consideration should be made there. So a question on the relative economics of a project like this, the solar and storage, as compared to the economics of continued use of that peaker plant that's in place, or a similar peaker plant. Could either of you speak to that economic proposition there, and also, aside from economics, are there any barriers to making that switch from traditional fossil fuel resources for peak needs into more distributed solar and storage resources?
So
yeah, I can speak to that.
A lot of really good questions in there. Yeah, JP, you wanna start, and I can follow up?
Sure. So I don't know the cost of the RMR, the run must run that the Dynegy plant was operating under. That was a PG&E asset, so we don't have those costs. What I can say is that the RA market for system, local, and flexible RA, which are the three types of resource adequacy that we procure, is very tight right now and pretty illiquid. There are some markets where it's very difficult to get RA, and the pricing on the batteries that we have gotten, both the front of the meter batteries as well as behind the meter batteries, are kind of cost effective and in the market, if you will, when compared to other resource adequacy offerings that we are evaluating. So to the extent that the Dynegy plant being shut down was an economic decision, in addition to an environmental and equity decision, as Michael alluded to, if that was an economic decision, then the results of that is that new battery resources, which are economic, are therefore more economic than the Dynegy plant, which is being shut down for an economic reason. A equals B, B equals C, A equals C. So I think that's kind of the most light I can shed on it, not having, and even if I had it, not being able to divulge the pricing associated with running that plant.
So I would agree with everything that JP said. I think he hit all the keynotes, and to add just a little bit more context, or to build from what he mentioned, the CAISO does a transmission planning process. I think it's either every 2 years or every 3 years, and they come up with essentially the portfolio of investments that they recommend to their regulator, which is FERC, to carry forward. Some of those investments are RMR contracts, right? That's the money that CAISO is paying out to discharge its responsibility for bulk power system reliability. The analysis that CAISO did indicated that retiring the RMR contract and facilitating the procurement instead of a portfolio of clean energy resources that will bring the Dynegy plant offline actually is more cost effective than maintaining the plant's operation. So even if you were to completely ignore the environmental and social equity benefits, which of course one should not, but even if you were to ignore them, you would still be looking at an economic argument for bringing the plant offline from CAISO's perspective. And that also, of course, makes sense for us and for EBCE too. So I think that the case here is pretty strong fundamentally on the economics.
Great, thank you. A question about the backup power capability. So this is a question, given the understanding that lithium-ion batteries tend to be 4 hours in duration or less, what is the backup power of projection for these projects as far as duration? What are you looking at as far as critical loads? Or I know that can be different from building to building, but do you have any sense of what level of backup power would be provided and what systems may be supported through the batteries?
Yeah, great question. So again, we would not be looking at offsetting, all of the load in each of these facilities, for example. That's not how we currently contemplate the project configuration taking shape. So it's not, unfortunately, going to be able to maintain the power in each tenant unit in the event of a grid outage. But we will be able to maintain the subset of that power demand, which powers, critical facilities operations within each multifamily property. So again, that's going to be elevators, emergency lighting, and common area cooling, essentially. So you're right. Typical lithium-ion battery duration is about 4 hours if you look at the total amount of discharge of the battery. But really, I think folks understand this, it's a megawatts versus megawatt hour calculation that you're looking at, right? If you use fewer megawatts, you have a longer megawatt hour duration, right? So you can extend the life of your battery, 10, 12 hours if you need to. It just means that it will have less power output per hour that you're using it. So in the case that we're talking about here for these multifamily properties, if we're talking about a relatively low amount of power output per hour from the batteries, we see it very realistic that these batteries can provide, 10 or 12 or more hours of backup power to the critical loads in the facility.
Yep. Excellent. Yeah. And yeah. Go ahead, JP.
Yeah, I would just add, one of your previous questions that I didn't answer on RMR, which relates to this as well, is what are some of the challenges to deploying batteries and using them for resource adequacy? It really speaks to this duration question. So, many of the batteries that are going in now are kind of 2-hour, 4-hour batteries. As we approach our SD100 targets, then duration is going to become more and more critical, having longer duration batteries in the market. And, but you can really look at battery duration in two ways. The current view is with few batteries in the market, a lot of those batteries, we will have a need of 10 and 12-hour batteries in the market. But as batteries penetrate the market and we have more and more of them, a 10-hour battery is equivalent to 5 2-hour batteries that are in the market called on in sequential order. So, as battery penetration increases, as we have more distributed assets that are feeding products like this, the resource adequacy product that we are buying, as electric vehicles, are allowed to interconnect to the grid and warranties are changed on vehicles such that they can discharge into the grid. Once you have a very, very high penetration of batteries, it doesn't matter if they're 12-hour batteries or if they're 2-hour batteries and you just have a lot of them. What we need is capacity to call on that capacity when we need it to meet our grid loads. And so, we do need to answer that duration question, but ultimately we need to just put a ton of batteries onto the grid that we, as the LSEs in the marketplace, have, some amount of control over, recognizing that those batteries have a primary purpose. As Michael said, the primary purpose or one primary purpose for these batteries is resiliency. So there's 20% in the battery that's not touched. That makes sense. That's why the customer is buying it. We as a load serving entity, as a grid operator, you don't get to touch that 20%. Same thing with vehicles. Vehicles have a primary purpose. Somebody needs to get from A to B, but in often cases, there's a lot more energy in that vehicle than is necessary to get from A to B. So as this market evolves over the next couple of decades and we see higher penetration of batteries, there's going to be capacity that we can call on. And the challenge and the opportunity is how do we figure out ways, business models, and customer engagement strategies to have a high degree of distributed participants in the marketplace that we can call on when we need to in order to keep the lights on and the cost of electricity reasonable.
Yeah, thank you, and that's a really great point. That a lot of people look at the what's essentially seen as the limitation of lithium-ion batteries, but it's really more of an economic limitation. As you said, if you have a 4-hour battery, that's at 4 hours at the full capacity, but it doesn't mean that you can't draw on half the power rating for the battery then for 8 hours or derate it in additional ways. It's really just a matter of the price signals that you're getting for delivering that power and the price point at which batteries are coming in, which is constantly dropping. You mentioned engagement there. There was actually a question on stakeholder engagement. How did you go about stakeholder engagement for this project?
JP, do you want to start, or I can, whatever you prefer?
Yeah. So there was kind of the high level stakeholder engagement was, at FERC and PUC and with, the IOUs and ourselves around what do we want and need to do with this peaker plant, and there was a strong level of community support across the Oakland community for shutting down that peaker plant, which had long been a thorn in the side of local community activists. So everyone was pretty aligned, was very aligned, that plant needed to be shut down. So we had that community support to engage and roll out on this strategy. And then I'll let Michael speak to kind of the community engagement and enrollment aspects of this project in particular.
Yeah, so again, totally echoed JP's comments on the need to look at the regulator and market engagement. For us, we have a very robust set of relationships with a lot of affordable multifamily housing providers throughout Alameda County. At this early stage in the project, we will be delivering the resource. Our contract with EBCE starts in January of 2022, so we have a little bit of time between now and when the resources will come online. But our job in these early months has been to start reaching out to some of our existing partners in the region and figure out which of their facilities are going to be the most suitable for these types of projects. Which customers are the most motivated to be a part of the solution here, and then kind of build the pipeline that translates into site development and project delivery. Critical part for us really is ensuring that we are sizing these projects in the right way, and that we are engaging the right customers, and that folks whose buildings are going to be touched by these projects feel engaged and empowered as part of the process too. But our first level of outreach will be to again our partners in the affordable multifamily housing community to figure out kind of how we look at that first pool of sites to consider addressing.
Great. So I know we're pretty well past the hour here. I think we got time for one, maybe two more questions. We've only really gotten to about half the questions that came in. So sorry to folks that didn't have their questions answered. There's been a lot of interest here. Please feel free to reach out to myself, or I'm sure JP or Michael would be happy to follow up with you. So we'll get to one or two more here before finishing off. Question about, were there any regulatory hurdles while trying to cite batteries, or I don't know if they've been cited yet, but as you go through that process, do you anticipate a question about fire department or Department of City Planning?
Yeah, so permitting and interconnection are critical considerations in cases like this. There are costs and process variables that we need to be very cognizant of, and each jurisdiction is going to have its own kind of variation on that. So you can call it an AHJ, an area having jurisdiction. It's typically can be county level. The permitting requirements can be, again, they can vary and they can be somewhat challenging. Interconnection, that's going to be predominantly a PG&E issue that we navigate here. We have experience in the solar and storage space on multifamily properties. It's still an emerging market, and figuring out kind of how we optimize permitting and interconnection for assets of this type is kind of an ongoing conversation for us. We are really interested to figure out kind of what the best and most efficient model for that, taking into cost and timeline considerations, can be. And I'd say we're really excited to continue that conversation to figure out how we make this as efficient and time effective as possible to bring projects of this type to greater scale. So I'd say it's very much on our radar. We've swum these waters before, and we look forward to doing so with even more efficiency in partnership with local governments and PG&E.
Great. So do one more question. I'm sure about this as well. So for a master metered building, how do the bill savings impact tenants? How is that passed through? If you could address that.
Yeah, great question. So for master meter buildings, oftentimes it can be in the form of a rent reduction. That's a pretty straightforward way to do it. A bunch of different models that facilities owners and operators, the bill payers, have the opportunity to leverage. But a rent reduction when customers aren't paying their actual energy use themselves is a pretty straightforward way to do it. Again, a number of different options, and we don't, it's kind of based on the requirements in the virtual net energy metering tariff that we at Sunrun don't set. That's a CPUC, California Public Utilities Commission jurisdictional tariff. But we, of course, our job on the Sunrun side is to ensure that we are able to meter and account for the output from the solar generation so that there's a good kind of paper and data trail to figure out how those benefits then need to be allocated.
Great, and just to verify, the question came in that there is no obligation on the tenant side, right? There's no payment that they have to do for this. It's for their participation, and no kind of contractual obligation on their side. Is that right?
That's correct. So in a case like this, Sunrun's contractual relationship is with EBCE for the resource adequacy delivery, and for the siting of the physical assets and the bill savings and the resiliency, that will be in the time of use benefits. That will be with the facility owner. So in the case of the project with EBCE here, it's affordable multifamily properties, and it will be with the property owner, not the individual tenant. That's where the contractual relationship from Sunrun's perspective will reside.
Great. Thank you so much. Thanks to everyone that's stuck with us through the end of this, and sorry to those that dropped off. Sorry to everyone whose questions did not get addressed. Again, please do follow up directly. I'm sure everyone would be happy to give you an answer to your questions. Thank you so much, JP and Michael. This has been a great webinar, really valuable information here. So thanks to you so much. And with that, I'll turn things back over to Mari to close things out for today.
Great. Thanks again, everyone, for participating in the webinar. Just one final note to make is that we do have an upcoming webinar, Optimizing Energy Storage Tool. It'll be on November 6th from 2 to 3 p.m. And if you're interested in registering for that, the link is available here. Thanks, everyone, for attending.